Thank you for staying until the last presentation of the day. Usually, the last one is very stressful one because we're just before the closing keynote. Okay, so today we're going to introduce you our work on the vulnerability identification in Android phones. And the vulnerability we're going to discuss is quite related to the infamous problem of Android fragmentation. That is why we call it the nightmare of fragmentation. So this is actually the first time we give talk in Hack in the Box. So please allow us to do a quick self-introduction. And this is Qing. He is currently a senior Android security researcher from Xiaomi, China. And his research is on the Android security and payment security. And myself, my name is Guangdong, and I am currently a lecturer from Singapore Institute of Technology, which is a quite new university in Singapore. And my research is on mobile security and protocol analysis. Okay, the agenda for today. First of all, we're going to introduce you not introduce, but give a quick review of the Android fragmentation and some discussion on its insecurity. And then we're going to give a summary on the vulnerabilities we have found and we have studied. Okay. So when we talk about Android fragmentation, we usually talk about two aspects. The first one, we call it version fragmentation. If you look at this figure, at any particular time point, there are various versions of Android running on the customer's devices. Okay. The second aspect, we call it brand or device fragmentation. And this one is basically shows the market share of different Android phones from different manufacturers. And you can find the Samsung share the largest one. And you also can find Huawei here, Google here. So in this diagram, each cell, each rectangle stands for a model. So what you can find is there are thousands of Android devices, different model running currently. Okay. So what is the problem of such kind of fragmentation? The first one is since different model, different device may have some special chips, special sensors, so they have to do some customization on Android operating system to adapt for that. Second, it's not every manufacturer will remain consistent with the official update. Okay, and the third is even the manufacturer realize it's necessary to follow the official update. Sometimes maybe the customization is too significant such that the update from official is no longer applicable. Okay, so because of this, the thing is we have already been talking about the Android fragmentation for quite a long time, but in terms of vulnerabilities, it is seldom studied this problem. That is the motivation of this work. So this is basically a list of the vulnerabilities we have found, which is highlighted ones. And we also studied two categories of vulnerabilities that already been known by the public, but maybe still exist in current Android devices. And we call this a legacy vulnerability problem, which is highlighted here. So you can find that most of the vulnerabilities kind of system crash due to the problem in the framework, or because some null reference in the binder services, or because of the Android index array index out of bound. We also find some problem of privilege escalation, which allow unauthorized application to read some sensitive data or call some sensitive functions out of its permission level. And also some authentication bypass, later we're going to show, and system reset problem, and some kernel-related ones. But unfortunately, today we will not discuss the kernel-related ones because these things are just reported to the manufacturer and still in discuss of the fix. Okay, so the first one is about system crash. So this category is because of the serialization resolving error in the components. As we know, Android has components of the broadcast receiver, the activity, the service, and so on and so forth. So if you look at this example, this one is actually found from Samsung. And you know that if we give an intent to another component, we can put something in extra, right? So what we do here is we just construct an empty serializable and put it in extra error of this intent and broadcast to this place. So this just simple 4 lines of code will crash the system. So in Samsung, we found that as if the intent includes such a changed string, substring, that intent is highly likely to be subject to this problem. Okay, so in this way, we have detected more than 150 vulnerabilities. So the interesting thing I want to share is initially we report this to Samsung one by one, and suddenly at a time point, we are able to find as many as 70 together. Then we report to Samsung. So they said, okay, we will not accept this as vulnerabilities in future. Okay, but later we are going to discuss is still a very serious problem. And the second kind of system crash is due to the NAR reference or a NAR reference in binder service or array index out of bound. So I'm going to show you one example which we found in Android 7. So this one is in the official Android. And in this particular method, process message, so what it do is it just using a message object get from another component as a parameter to invoke a particular function. So we look at here. So this function first will check whether the message, whether the object get from another component is null. Okay, so that is the first guard. If it is null, it will just terminate. Otherwise, it will go into this place. So what here do is it use a field of the object to call this catch.get function. So what happened is in this function, it uses this string, the field get from the object as a key to looking for some value in hash map. So what happens is if this thing is a null, it will crash the program. Okay, so we come back to here. What happens is if another component constructs such an object, which is not null to bypass here, but the field of BSSID is a null. So what happens is we crash this whole thing. Since this one is in the framework, it will simply crash the system. Okay? Another problem is array index out of bound. So what happens is we randomly choose some number and feed into this function. So we get a crash, and the log tells us it's because of the index out of bound. And we do not quite look into the program, but what we can guess is probably this function use some particular item of the array to fetch. I mean, use it as index because we set the index to be a very, very large number. So it may refer to some particular object in the memory. So this will lead to the index out of bounds and also lead to the system crash. Okay, so just now we discussed the problem of system crash, and you know, the Samsung's attitude is like it's not a serious problem, but in fact it is. It is reported that Google and its vendor Huawei may be sued because of the boot loop problem in Nexus 6P. Okay, so after that, starting from Android Nougat, Google may, because we seldom found problem in Android Nougat, so we guess probably Google may have introduced some mechanisms or may become very careful when dealing with this issue. So this mechanism may already prevent most of the system crash from happening. Okay, but this problem still extensively exists in Samsung phones. And also it has been reported in Galaxy S7 that the boot loop issues extensively exist in Samsung phones. Okay. The next vulnerability we are going to show is a system reset one. So the issue of this one is some interface to do the system resetting, the factory resetting, is exported. So what do I mean by that is, if we just broadcast such an intent under intent of action master clear, the receiver of this intent is actually maybe an activity. So what happens is, it will just prompt out the activity, which is a window you can do the system reset. Okay, and also we find another, we call it debug mode or engineering mode, which is if the user just type such kind of magic number in a dialer, it will activate the reset activity. Okay, so the problem here is we call it inconsistent authentication, which means if you just go to the system reset from settings, it requires the user to do authentication first. However, there still exists some, I would say, bypass the authentication. Okay. Such problem also existing in other. Sorry, here is in Chinese because we don't get time to prepare it in English version. So this one is fine from Vivo. And also the same thing, the user can just type this number to activate such an interface to do the system reset. And also the malicious application can construct intent which can do the same thing, basically. Okay, so next I will pass to Zhangqing to introduce on another two vulnerabilities. And he will also give you some demos. Okay.
Hello, everyone. Now let me introduce some vulnerabilities related with the stuff of the internet, such as the UXSS and the remote code acquisition. Why we focus on these vulnerabilities? Because they affect both browser and the web view. And these vulnerabilities are remote and which are very dangerous to the users when they surf the internet. What's more, the most applications that are used the web view when the phone do the things like showing a web page. So this company are always being tried to acquire the index about these vulnerabilities, the exploitation. So for a very high price, maybe someone can try. Now I will show exploitation about remote code exclusion on Samsung Note 4. Sorry, in Chinese word. Let me say the Android one is 5. I open a web view. So there's no port about the web view now. Then when we open a web page, that is our exploitation. Then the application will receive a shell now. Let's see here, it's open a port. So the attacker may connect to the phone remote. So this problem are very serious. The second vulnerability about our finding is authentication bypass. It also includes the bypass activation, just like the iPhone activation, you know. But this problem are kind of sensitive, so we are not show here. We show another problem. This vulnerability allows the attacker to reset the biometric data, such as fingerprint, face, and iris, which has been recorded for authentication. So this happened in an exported high probability activity. So when generated data and then open this activity, will bypass the authentication. We have made a video here. Sorry, later. When I open this activity, you can remove the data about all the biometric data, such as the fingerprint and the iris. So this may abuse on the apps rely on the biometric authentication, such as Samsung Pay. So it's a demo here. Here's the first is the right pattern. So we can say is the Samsung Galaxy 8. It's the newer now. It's the wrong pattern. Now is the exploitation. We can set ourselves password now. Then we reset the pattern of fingerprint or iris. Input the secret number our set before. So we can input our new iris here. Then we add remove all the fingerprint and add a new fingerprint. So now we can use our new biometric, such as fingerprint or pattern. Now is the new pattern. We use the face. Okay. It's the demo. Then someone may say that it only happens when the device is unlocked. If the phone is locked, it may not as serious as I'm said. Now we provide a method to bypass the fake recognition. Actually, some research and have made some attempt to bypass the Samsung's iris and face authentication before, and reported the same problem to Samsung. Samsung have provided advanced recognition in the new version, and here she put two ways. One way is the faster recognition, and you can close it and open it. We now close it. In this version, you can see just the last month now. After that, this research and Samsung think it's very hard to bypass in the new version, just this version. Is that true? Now we also a method to bypass the recognition, just use and print the photo. So we make a video here. Just a printed photo. So you can say, so easy. How about the other manufacturers? This is Huawei. The same kind of problems. Then we get a CVE like this. But the Huawei is well communicated and responsive. Actually, Google Pixel have the same kind of vulnerabilities. But then now all the activity are exported is false now. Okay. Finally, I will thanks for my friends Loding and Wang Shugui who have given me great help during the process of finding some of these vulnerabilities. Okay, thank you. Any questions?
So do we have any questions from the floor?
Hello. I'd like to find out if you have done any research on the iOS, because I understand these slides are all bashing on this Android. So any insights can we share on the iOS?
Unfortunately, we haven't done
no problem. We look forward to your
yet.
research. Yes.
Yeah. And this, I would say most of the vulnerabilities are actually quite related to the IPC in Android. So maybe in iOS, different IPC models are used. So probably this kind of vulnerabilities may not be detected in iOS. Yeah. Thank you. Thank you for your suggestion.
Okay, so do we have any other questions?
Oh yeah, so this is just like the research and that's it, right? Is there like anything ongoing?
Pardon?
Is there any more studies like research are ongoing? Because there's like a newer version of Android coming out.
Okay, so currently, just to be frank, we are going to the kernel level. So we are trying to say, because we are basically studying the problem of fragmentation, right? So I think more of the most significant fragmentation is on a driver, on a device driver, because different devices might use different sensors, different chips, and we feel there must be lots of more serious problem in the kernel level. So currently, one direction we're looking into is to say the device drivers in current Android phones, say whether there's some problem inside.
So like, will there be another kind of thing like this later? Cause there's like
Yeah,
newer
probably next year in Hacker in the Box, if we still get invitation, probably we're going to share such kind of
Because
work.
like Google say that they're going to somehow solve this problem of like vendor specific customizations, that kind of thing.
It's really difficult to solve it because first of all, the Android OS is kind of open sourced project. So let's say there would be no reason for Google to actually look into how other manufacturers do the customization. So what we can do is just to remind the manufacturers of such kind of problem when they do customization, especially when they do some sensitive thing like change the settings, change the device drivers, and change the authentication things. They should keep this in mind.
Yeah, there are even individuals that do this. Like they use like they flash their ROM or that kind of thing.
Yes. Even individual developers can do such all customizations. So really, there may be no control. I mean, after the Android already released, new version release, update release, patch release, still they lose control. Depends on the manufacturer and the developers to decide whether to do the update, whether to look into the problem, to patch it, so on and so forth.
Yeah, okay.
Yep. Thank you.